Welcome to this lecture. We'll just try to discuss simple Cartesian double integrations and how to evaluate them. Now, what is a Cartesian double integral? All of us are aware from our school days that Cartesian coordinates in 2 dimensions are x and y, and in 3 dimensions x, y, z, and so on. So a Cartesian double integral is such an integral which will have a function of 2 variables, and the 2 variables are x and y, a double integral operator, and an area element dA. So this is a standard representation of a Cartesian double integral. Now, when you evaluate a Cartesian double integral, the region of integration is broken down into a grid or a mesh consisting of small rectangles, and the continuum of this will produce a double integral. So you can find the area of each small rectangle either by dx into dy or dy into dx, because that is how you compute the area of a rectangle. So a double integral in the Cartesian frame looks like this. So what does a simple double integral mean? This essentially means that when the limits are available in the problem itself, that does not always mean that we'll be able to successfully integrate, because everything depends on 2 things. One is the limits and one is which function are we integrating. So there are 3 possible scenarios. This is the easiest, of course, where you have constant limits for both the integrals. The order can be dy dx or the order can be dx dy, and this is considered one of the easiest of the cases. A slightly advanced double integral where one pair of limits is constants, I mean the outer integral will carry constant limits always, but the inner integral may contain functions of x. So those are the limits for the variable y. Therefore, the order has been displayed as dy dx. The third one can be guessed by you. Here we have the outer integral carrying constant limits, but the inner integral is carrying variable limits which are functions of y. And these limits, alpha y to beta y, are the limits for the variable x. Therefore, dx first and then dy next. So essentially, these are the 3 possible scenarios when you evaluate a Cartesian double integral. The easiest being, of course, the first one. The 2 possible orders of integration that we just now discussed, where the area element dA is written as dy dx in one case and dx dy in the other case. So these are the 2 possible orders. Which of them should be picked up is a question of careful consideration, which will be discussed during problem solving. What are the evaluation strategies? Now let's come back to the first integral that was displayed earlier. When you have constant limits for both the variables x and y, like x has got limits a to b, y has got limits from c to d, then if you actually trace this region, you'll find it will be a rectangle or a square. So whenever you have both pairs of limits constants, then the region of integration is either a rectangle or a square, depending on the dimensions. So when you have this situation, then you can integrate f of xy first with respect to y, then with respect to x. Of course, be careful how you are fixing your limits. Because dy happens to be appearing first, you must integrate with respect to y first, Therefore, the inner integral should carry limits c to d. And of course, the outer limits will be a to b. Conversely, if you have decided to integrate with respect to x first and then y, then you'll have to interchange the order. So it is a very simple matter to interchange the order of integration in the case of rectangular and square regions, because it's only a swapping of the limits. So one can choose an appropriate order, either the first one or the second one, based on the ease of integration. So let's look at the other scenario where the limits are not constant in both the variables. So we have one pair of constant limits, that is y limits are constant now, but x varies between h1y and h2y. Where are these two limits coming from? Let's look at this diagram. So you have two dotted lines which you can observe, which are parallel to the x-axis. Those are the equations y is equal to c and y is equal to d. So in that order, you fix the y limits. And you can see two curves, one blue curve and one red curve, left and right. The blue curve has the equation x is equal to h1y, and the red curve has the equation x is equal to h2y. So x is equal to h1y will form the lower limit for x, and x is equal to h2y will form the upper limit for x. So we fix the limits in that particular order. Of course, it's an art to write these limits, which I'm going to explain in detail very soon. But if you have done this job of drawing the lines and curves and then fixing the limits, the double integration looks like this. I is equal to integral a to b, those are the y limits, then integral h1y to h2y, f of xy dx dy. Once again, we should hope that we will successfully integrate this, but in case we are not able to, what should be the strategy? So in the lectures that are going to follow, so we will read at that time how to proceed with integration when the limits do not accompany the problem. But when the limits are not coming along with the problem, then there must be some other information available in the question from where the limits will have to be extracted. So that is where the geometry aspect will enter the problem. So that's going to be a detailed lecture that I'm going to discuss with you all. Then we must learn types of regions. Two very important region classifications are the Rx region and Ry region, generally not published in many books. I'm going to take you through that particular concept. And then how to fix. First of all, we must understand what is an Rx region. Then once Rx region is understood, how do we fix the limits of an Rx region? In a similar way, having understood Ry, we must know how to fix the limits of an Ry region. Then there are much more complicated situations where you may have to split the regions into more than one Rx region or more than one Ry region. So what are the intricacies around that particular strategy? And there are also other evaluation options that you are going to see in double integration. So dear friends, this is just an idea about what Cartesian double integrals look like and how to read limits from diagrams. But how to draw diagrams is a very, very important part of our future discussions. So I'm going to take you through that journey through detailed lectures along with relevant problems. Thank you very much.